Hi everyone, this video is going to cover up first of all what are skew lines. Um, First I'm going to talk about skew line concept, and first of all I'm going to teach you when the lines are skew. How do you find out the shortest distance between skew lines? So these are going to be the objectives of this video. Now generally when two lines intersect, you can see that they intersect, their x, y and z coordinate in the space are going to have the same value. While in certain cases when two lines like first line runs over parallel to the other line, or in space there is a gap between those two lines, we call the lines to be skew lines. Okay, so the objective will be how can we find out when two lines are skew lines, and how do you find out this shortest distance? So beginning up, we're taking one example. So consider these two examples. So first line I'm taking is the vector equation of the line is 1, 3, 1 and lambda times 1, negative 1, 2, where lambda is a parameter, so you don't have to worry about. 5, negative 1, 6, mu times 1, 1, 3, here's another parameter. Now I want to check when these two lines are skew lines. So first of all, what you do is you follow the standard procedure for finding the intersection of the lines. So convert both the equations in parametric form, which is going to be 1 x, y, z. Basically it's going to be 1 plus lambda, 3 minus lambda, and 1 plus 2 lambda. Second equation is going to be r, basically x, y, z, going to be 5 plus mu, negative 1 plus mu, and 6 plus 3 mu. So these are going to be the two parametric forms for the lines. Now what happened is that in case if these two lines are intersecting, they must have the same common coordinate for x, y, z. So what I do is I equate x with x, I equate y with y, and equate z with z, and see what do we get. When I equate x with x and y with y, we're going to get 1 plus lambda equals to 5 plus mu, then 3 minus lambda equals to negative 1 plus mu, 1 plus 2 lambda equals to 6 plus 3 mu. Now what I'm going to do is I'm going to make three simultaneous equations from here. So the first equation that I'm going to get is mu minus lambda is negative 4. The second equation which I'm going to get is mu plus lambda equals to positive 4, and then I'm going to get 3 mu minus 2 lambda equals to negative 5, which is using these equations. Now you can solve any of these three equations and get the value of mu and lambda. So when I solve these values, let's say when I use these first two equations and solve, I'm going to get 2 mu equals to 0, which means mu is 0, and lambda is gonna be let's say 4. Now plug this value in the third equation. Now to check, now if the third equation doesn't get fulfilled with these two values, I'm gonna say that the lines intersect is not possible. So I'm gonna put these two values for mu and lambda and check. So 3 times 0, negative 2 times 4 is not negative 5, which is not correct. So what you can do is you can conclude that these two lines have the same x coordinates and y coordinates, but the z coordinate is different. It means that the lines are skew lines. Now explaining you the further example, how can I find out the shortest distance of the lines? Alright, so first of all, before you find the shortest distance between two skew lines, you must understand that these any coordinate on the line can be expressed, that can have the vector equation can be expressed in the parametric form. So I'm taking just a general coordinate of any one point on the line L1 and a line L2. So I'm taking A and B as the two respective points. I'm writing the general coordinates that I get with 1 plus lambda, 2 plus 3 lambda, 3 minus lambda. Here if you use these two, I'm going to get these coordinates. So what happened is that when I'm using these two coordinates, I can find out this vector AB. So vector AB is going to be OB minus OA, which is of course this coordinate minus this coordinate. So you can say this is vector OB actually, and this vector, if you write this one in vector form, that can be your vector OA, which is gonna be 1 plus lambda, 3 minus lambda, and 1 plus 2 lambda. So when I subtract it, I'm gonna get this particular equation, this particular set of values for mu and lambda for vector AB in terms of mu and lambda. Now the next process is, how do we process this data to find out the shortest distance? So to find out, now we already derived vector AB, as you can clearly see that this was in the previous step out here, which we derived. So this part I'm going to use it now for finding out the further values. So what you do is, because you clearly see that these two, this vector is perpendicular to this line as well as this line, because that's what is the shortest distance. Now when you calculate this, I can take dot product of this vector with direction of this line, which is this one. So I have extracted only the direction. I don't care about which point does it pass through, and also the direction of this line, which is 1, 1, 3. You can check it out here that this is 1, 1, 3 for the second direction, this particular part I'm talking about, and the direction of the first one is out here. So that's what I'm going to use now. So dot product of AB with this direction has to be 0. Dot product of AB with this has to be 0. So beginning up with the dot product, this is what exactly going to look like. So once you take the dot product of mu minus lambda plus 4, and this basically this vector AB with the direction of the first line, we get this. So you multiply this out with this out with this out with this, and you add them up. That's a dot product, and that must be equated to 0. Now this particular equation, if once you simplify, it simplifies to mu minus lambda equals to 1. Second equation, when I take vector AB with 1, 1, 3, I'm gonna get again the dot product of 0, and that simplifies to this particular equation, which is 11 mu minus 6 lambda equals to 21. Now I'm going to solve these two equations to find out the value of mu and lambda. So that's what I've done. If you solve it, you're going to get mu equals to 3 and lambda equals to 2. So now what you do is, the next step is to figure out the vector AB. Now how do I get vector AB? You plug these values out here. So mu and lambda value out here. So that's what you're going to get. Now once you do that, you get vector AB as 5, -1, and 2. And if you agree with me, the shortest distance is going to be the magnitude of vector AB. Hope this helped you to figure out this particular kind of question.